Welcome to this presentation on connectors, the rod type of connector. My name is Mike Fiedler. I'm a designated support specialist here at Autodesk, and I'll be working through this presentation with you. So let's take a look at what we have for the geometry. We're going to use the rod connector type to model this system of trusses that we see in the image here on the right-hand side. And we've been given some criteria. We're going to apply a load in the minus y direction as this geometry is oriented in the schematic. That load will be minus 10,000 pounds force or 10,000 pounds force in the minus y direction. The length of the horizontal and vertical members are 120 inches long, and the cross-sectional area is 2 inches squared. The modulus is going to be 30 E6, and the angle of the diagonal member is 45 degrees off of horizontal and vertical. So in some of the prior examples, if you've been working through a variety of these journeys, is we have provided a model. And in this one, what we're going to do is start with the model entirely from scratch inside of Inventor, and then we will go into Inventor Nastran to complete the setup. So there won't be a model to download, but I am going to go through the entire setup of this particular example now. So let's go ahead over to Inventor and take a look at how we do this. Okay, so here I am inside of Inventor, and I'm just going to say that I want to create a new part. And I'm going to start a sketch, and our system was in the XY plane, so I'm going to go ahead and select that plane to start with. Now, when we get into the Nastran environment, the connectors need to be connected to something, and that something can either be some sort of CAD geometry, so we can take a vertex on the CAD geometry, it can be a work point, or it can be a combination of those items. So in this case, we know that we need the connectors to go from, say, the origin to 120 inches over horizontal, 120 inches up in vertical, and then a diagonal member. So what I'm going to do is I'm just going to start creating points. So let's go ahead and drop a point, and then I'm going to drop another point on the horizontal axis, and then I'm just going to dimension between those 2 points, and we'll make that 120 inches. Let me go ahead and zoom out a little bit. Let me add a point on the vertical here, and I will dimension that. And that's going to be 120. And then we need one additional point out here, and we'll dimension that horizontally and vertically. 120 units or inches. Okay, so now what we have are 4 work points, and we can use those to add the rod connectors to. Okay, so what I am going to do is just finish this sketch. And if I right click on that sketch, I can turn off the visibility of the dimensions because we don't necessarily need those when we move into Inventor Nastran. Again, there's our sketch. And I'm just going to go Environments, and then we'll go Autodesk Inventor Nastran. So once we come into Inventor Nastran, now we can begin to define our structure, and it's quite simple. As far as adding connectors, in the panel across the top, you will find the connectors option. And when a connectors opens up, you can choose what type of connector you're going to define. In this case, we do want it to be a rod connector. And for our connector, what we have to do is define the endpoints. So I'll highlight one of those fields, just select one of the work points, and again, it could be a vertex on your geometry. And select another point, and I'm going to define what the cross-sectional area is. And then, in order to create the next one, I'll just go ahead and hit Next, and again, define my point so I can go from there to there. Hit Next, and we go there to there. All right, so pretty simple as far as creating the connector is concerned, right? I don't think there's anything too difficult there. In addition to having the cross-sectional area defined, one of the other mandatory items would be the material. And right now it's saying that it's a generic material. So we'll take a look at that in just a second. I don't think that I need anything else defined here. All looks good. Let's say OK. So you can see in the menu tree on the left-hand side, now we have our connector and generic material. What we can do is edit that, and in the description of the setup of our problem, we were given a modulus of elasticity of 30E6. So we can type that in right there. Elastic modulus PSI. So that's good. Our units check out. Let's say OK to that. And then as far as setup goes, the other things that I need would be my constraints and the force there. So we'll do the constraints. They are currently set to fully fixed. Let's go ahead and assign a name. Fixed. And then I can select the locations of my fully fixed boundary conditions and say OK. And then we have our force in the -y direction. So let's go to loads. Set the force currently. Selected the entity of this node, and that's going to be -10,000. Okay. We'll say OK to that. Now, one of the things that we're going to check, or some of the things we're going to check, of course, we want to see what the displacements are. We want to know what the stresses are, but we also know from hand calcs we can figure out what the forces will be in those members. The program will not by default output those values, but we can turn it on. What I'm going to do is right click on analysis 1 and say edit. And here in my analysis output controls, I can tell it that I also want it to output the force. We'll say OK. At that point, we can run the analysis. Let me assign a name to it. I haven't saved my model yet, so that's fine too. Connector rod. And we'll hit save. So that, again, the analysis should go very quickly. It's a very small model. All right. Now, when I come into the results environment here, you can see that we have displacements, and the values range from 0 to 0.016. And if we look at the geometry all looks blue. You can see that it is adding some type of visualization to those connectors based on the cross-sectional area that I've added to it. So in order to see the display of the contours, whether that's a displacement or stress, if you go up to Object Visibility, go to the pull-down menu there, then we can turn off or uncheck connectors there. Then we can just see them as line representations. So there we go. And then we're going to start to interrogate. So maybe the first thing that we look at is displacement. Well, if I look at my max displacement, we know that it's a nice small displacement, so we don't have anything wrong which is causing large rigid body movement or rotation, so that's good. But we also know what the values should be. And from the x displacement, my x value should be 0.004 from a hand calculation. So if I look along the x-axis, as far as displacements are concerned, I can see the displacement there, max displacement is 0.0041. And then for the y direction, we expect, again, our force is in the y direction, so we expect a minus 0.0159 for that. So let's look along the y-axis. And we see minus 0.016 rounded up, or 0.01586, which matches up with the 0.0159 that I arrived at with the hand calculations. As far as the forces, let's take a look at the forces in our different members. So what we can do is go to the pull-down menu, and forces are going to be found under Other. And there you can see the rod forces, right? So what we want to do, or maybe the easiest way to look at the individual members, is to go to Probe. And as far as the forces are concerned, for the vertical member, I arrive at a value of 7929. So there is, just had to reference my notes, there's 7928.9 or 7929. The diagonal member, I came up with a value of 2929. And if we hover over that, again, we see 2928.9. And then on the horizontal member, I came up with 2071. and we can see that value there for the force. And then finally, to check our stresses, we go to stress, and we can interrogate. Vertical member should be 3965, and there you see 3964.66, so again rounding. Diagonal member should be 1465, and there we see 1464.5, and the horizontal member should be 1036, and there we see, again, rounded up to 1036. So again, very simple to create them. You just need to define 2 points for each one of the rods. You define what that cross-sectional area is. You have some fields where you can input some additional information. For instance, if you wanted to add non-structural mass, and non-structural mass would add mass to the rod without making the rod more stiff, for instance. So there are additional things that you can do in the setup, but as far as defining them, very simple. You just need to either have work points out in space, which you can define in Inventor, or you can attach them. Imagine that I had a CAD body up here. I could attach it between a CAD body and this work point. Or again, if I had a CAD body here and a CAD body here, I could use the vertices of the CAD bodies to add my rod to that. So any one of those means will work to define it, and hopefully you find that useful. Thanks.